This locomotive is the Wedge. We've got the top off so that we can have a look at all the interesting stuff inside. This is where we drive it from. Control panel, two bogies as you can see, and a pair of mobility scooter batteries in the middle. Here we've got a pair of ordinary domestic circuit breakers. One of them connects the battery or disconnects it from this socket here, which is the battery charging socket. At the end of a day's run, I simply plug a mobility scooter charger into there and leave the batteries in the locomotive the whole time, and that takes care of those. The other breaker, of course, applies power to the rest of the locomotive. I wanted to do something rather different. Just about all the other electric locos use ordinary conventional brush motors. I wanted to do something different, and I've gone for brushless motors. Up under here we've got the main brain of the whole thing. This is a little computer board and a few extra bits on a piece of matrix board. It's the embed controller as the central computer, with a few bits and pieces that I need to interface it to the brushless motor drive boards. So we've got four cable forms here, four bundles of wires which go off to each of the four motor drivers. Now this is where brushless motors differ, in that you can't just wire the motors up in parallel or series. Each motor needs its own tiny little control board, which, as you can see, it's only 2.5 inches or so square. It's not very complicated at all. And really, in block diagram terms, if you lump the little tiny control board together with the motor, that block really does look and behave very much like an ordinary conventional DC motor. So as far as the control panel up here is concerned, it doesn't really know anything about brushless motors. It's just providing exactly the same sort of signals that it would send to a PWM controller in any other DC motor control scheme. And these little boards here, each one drives a separate brushless motor, one per axle. And because the motors were just a bit too long to fit between the wheel backs, I've gone for a tooth belt drive, which turned out to be very efficient as it happens. Front of the locomotive, we've got the two other drive boards for the two other motors, and the motors are quite hard to see because they're tucked away right down at the bottom of all of this. Don't know whether you can see the motor just under there. The motor's got a little pulley on the end of it, which drives a much bigger pulley mounted on the wheel back there. We've got a speaker in there, so that we've got a couple of sound effects. It's reasonably well balanced. There's a lump of 4B1 in the lid that fits in that space there to just balance up the control panel on the back here. When I was designing this, I was also writing up for publication in one of the model engineering magazines, so I deliberately went for a design process that I call design by catalogue, to keep the electronics as simple and understandable as I could. So I've gone for a black brick here, which I found in the catalogue. That is a black brick which is designed to drive motors, and the little board I've designed to go around it just contains the few extra bits it needs to provide all the right signals in the right sequencing and phase, etc. This is the third season now, the third year that we've been running it, and we bring it down here and run it for 3 hours or sometimes more. We've run it for a lot more than that at the flower show, and it's carried on going without killing the batteries entirely. When I take it home, I just put it into the workshop, plug the charger in and forget it, and it's ready for rolling the next time. Maintenance wise, once a year I take the lid off and put a few drips of oil on the couple of bearings here that are not roller bearings. The main axle bearings are packed with grease, roller bearings, and they don't really need any attention at all. So low maintenance, that's one of the key things about the design. That's it.